All right, so part C, problem C here, we're going to be graphing. Let's use this space down here. We're going to be, so problem C, we're going to be graphing y equals x squared minus 9. Well, we should know what that graph looks like. That's just a transformation. We have a y-intercept of negative 9, and if we set to find the x-intercepts, if we set y equal to 0, then we would have an equation that's 0 equals x squared minus 9. We could do this one of two ways. We could add 9 to both sides. We could take the square root of both sides, and we would get x is equal to, can't just be 3, there's 3 there, but what about this guy over here? That's negative 3. So x is equal to then plus or minus 3. So we have, this would be the easiest of the three we've done in this section. We have negative 3 and 3 are the x-intercepts. And so let's fill in some of those details up here. We have y equals x squared minus 9. I think I barely squeezed that in there, x squared minus 9. So again, the domain of all of these functions is always all real numbers. The range would be from the lowest y to the highest y, negative 9 to infinity. The vertex, we already talked about that, being at 0, negative 9. The intercepts would be negative 3, 0, 3, 0, as well as 0, negative 9. And then we have a min. We have a min value of negative 9. The axis of symmetry is the vertical line that divides the left half of the graph from the right half of the graph, splits the vertex. I mean, it splits the graph, goes right through the vertex. And x equals 0 is the equation of that axis of symmetry, increasing from 0 to infinity and decreasing from negative infinity all the way to 0. And we kind of held off on answering this guy right here. So problem 61, when is this function, when are the y values on or below the x-axis? Well, on the interval, so if you plug in any real number in between negative 3 and positive 3, we would get a y value less than 0. We'd get a negative number, right? So if you plugged in 0, you'd get 0 squared minus 9. That's a negative number. That's true. 2 squared minus 9, that's a negative number. Negative 2 squared minus 9, also a negative number. If we plugged in negative 3, we'd get 9 minus 9, that's equal to 0. So we want to include negative 3. We also want to include positive 3 because 3 squared minus 9 is also 0. Because what we're looking for is all of the real numbers x that would cause x squared minus 9 to be less than or equal to 0. And that's exactly what we find by looking at the graph. And after going through all of that, then we have all of the characteristics, we have the graph, and we have the solution for problem 61.